The quality of busbar welding inside a battery pack is a critical factor in ensuring the battery's performance, lifespan, and safety. Conventional visual inspections could sometimes miss potential defects, such as insufficient penetration depth, even when welds appeared visually sound. In physical tensile testing, the outcome often depended on the skill of the inspector, leading to issues such as missed defects and rejecting parts that were actually acceptable. In this video, we propose a new indicator for welding quality. Quality can be quantified through electrical resistance measurement with the RM3546 resistance meter. For the demonstration, we prepare a sample with different welding currents. In this video, we first demonstrate how resistance measurement can quantify differences in weld condition caused by variations in welding current. We then introduce a method to eliminate the influence of temperature in resistance measurement. By using a sample welded with different welding currents, this video will demonstrate that different welding currents can be observed through resistance measurement. We will highlight key techniques in measurement. In this demonstration, the sample sheet is secured in a fixture specifically designed for this demonstration. The welding currents used for the two welds were 12.5 kiloamps and 10 kiloamps. The fixture is equipped with contact pins used for resistance measurement. These contact pins are connected to the measurement terminals located on the rear panel of the RM3546. We will measure the resistance by making contact between the sample sheet and contact pins. The resistance after welding at 10 kiloamps was 129 microohms. Next, we switch to the 12.5 kiloamp sample. The resistance after welding at 12.5 kiloamps was 122 microohms. For this sample, the welding point at 12.5 kiloamps was 5.4% lower than the welding point at 10 kiloamps. In short, differences in welding current can clearly be seen through resistance. From here, we will explain how to eliminate the effect of temperature on resistance measurement. Generally, there is a correlation between resistance and temperature. Immediately after welding, the measurement point starts to cool, and the resistance starts to decrease. To demonstrate this, we will measure the resistance while heating the sample with a heat gun. The sample sheet is heated. As the temperature rises, the resistance increases. Once the heating stops, the sample sheet cools down and the resistance value decreases. In other words, there is a direct correlation between the changes in the welding's resistance and temperature. This change in resistance is based on the temperature coefficient of material being measured. This resistance change tied to temperature can be compensated using this temperature coefficient. However, this requires quick and accurate measurement of the temperature change of the metal. This is very challenging. The RM3546 can solve this problem. It can quickly calculate the DUT's temperature by accurately measuring the resistance for the DUT's non-welded area and using this area's temperature coefficient for the calculation. Now that it has real-time temperature, it can compensate the welded area's resistance in real time by using the welding's temperature coefficient. Thus, the RM3546 consistently outputs what would be the resistance value at a reference temperature, such as room temperature. Now let's compare the resistance values with and without this temperature compensation. The RM3546's ATC function. The RM3546's measurement values are displayed as a graph on a connected PC. We will heat the sample sheet and monitor the resistance, temperature, and temperature-compensated resistance, all output by RM3546. The black points are temperature, and the red points are the measured resistance of the welding. Once the heat gun is removed, the sample starts to cool, causing both temperature and resistance to fall. The blue points indicate the compensated resistance value using this ATC function. You can see that the temperature compensated resistance value is unaffected by the temperature change. To summarize, this video demonstrated that weld resistance measurement is a powerful tool to evaluate the quality of welding without waiting for it to cool. This method helps increase the takt rate of battery production lines. The Hioki 3546 resistance meter is the only instrument specifically designed to measure welding resistance in a production environment.